It is a pleasure to describe the concept and ideas of the consortium FAIRmat. FAIRmat stands for Fair Data Infrastructure of Condensed Matter Physics and Chemical Physics. The name reflects that the numerous PIs and task leaders of the consortium represent the Condensed Matter Physics section of the DPG, and we also have people from other societies. Within this group, we obviously have a high degree of interdisciplinarity, reflected by the research topics and by the very diverse expertise of the PIs, as you will see later. We have essentially the full community on board, individual researchers, as well as working groups, research networks, such as CRCs and clusters, universities, research institutions, and scientific societies. A data infrastructure and the definition of metadata and ontologies should be, in fact, needs to be an international scientific activity, and we are deeply embedded in the international landscape indeed. There is the European Open Science Cloud, where we are a member, and many more are listed here. We have close contacts and collaborations with our colleagues in the USA, for example, NIST, and other international players in China, Japan, Korea, and more. Several memoranda of understanding have been signed already. Our activity and influence is also reflected in numerous talks that FAIRmat members have given and are giving at international conferences on the topic of a fair data infrastructure. Just last week, Claudia Draxel was at the APS March meeting with this topic, with an invited talk. And we have organized and are organizing workshops, schools, conferences. We also started special lectures at universities with innovative topics. Let me only mention one special event, namely the International Conference on a Fair Data Infrastructure for Materials Genomics that was organized by FAIRmat, and it was the largest conference on this topic so far. There were also two satellite workshops, one by the Junge DPG on NFDI at teaching, very important. The follow-up conference will be in Shanghai in summer 22. Here you see the structure of the FAIRmat consortium and a sketch of the headlines of the work we are planning to do. Different areas have different color. In yellow, we have area A, the synthesis of materials. I will tell more about this in a moment. Then in green, there is the experimental material science. Computational material science is area C. Area D in blue addresses all the different issues in building and managing the digital infrastructure. We also need to demonstrate that things work and to convince people what all of this is good for. For that, we have use case demonstrators. Very important is user support, training, and outreach, because all these developments also have to be considered in future education and advancements of university curricula. We will also organize schools, workshops, and hackathons. Obviously, there's also administration and coordination. How are we doing, or how are we addressing all this? In very simple words, we will adopt an inclusive, user-driven approach to develop easy-to-use tools and an infrastructure towards fair data processing, storage, curation, sharing, and artificial intelligence readiness for future use of materials data. In fact, our outlooking interpretation of the acronym FAIR is that scientific data should be findable and AI ready. Let me go through the areas starting with the synthesis. This area is coordinated by Martin Albrecht from the Institute for Crystal Growth of the Leibniz Gemeinschaft and Claudia Felser from the Max Planck Institute for Chemical Physics of Solids. Both are renowned international leaders. The situation which we experience in synthesis so far is not satisfactory. Synthesis recipes are collected for personal use of the scientists, often only documented in handwritten lab notebooks. Log files created by the synthesis instruments are often not kept. This needs to be changed, and the group already started. to establish metadata ontologies and tools, to harmonize metadata schemes for synthesis and experimental characterization, to install computer-aided developments of synthesis recipes, interweaving experiment and theory, from yellow to green. This area is concerned with the enormous variety of experiments in the field. This is coordinated by Mark Reiner from the MPI for Chemical Energy Conversion and Christoph Koch, a leader in electron microscopy from the Humboldt University. The state of the art in this area is again noted in the gray box. Initially, FAIRmat will focus on the techniques noted here: core level spectroscopy, angle resolve photoemission, atom probe tomography, electron microscopy, and electron spectroscopy. We will start with these 5 exemplary methods, but then, of course, we will continue with others. The goals are, for example, the developments of metadata and workflows for the extremely diverse characterization methods used by the experimental condensed matter community, and to build an efficient and persistent linkage of data types to be implemented by means of laboratory information management systems and electronic lab notebooks. Area C contains my field of expertise, but it is much broader. It will be coordinated by Kurt Kremer and Tristan Bereau, both well-known leaders in the field of soft matter and polymers, and by me. The present situation is characterized by the huge variety of methods, for example, sophisticated classical simulations, Navier-Stokes equation, fluid dynamics, highly complex quantum mechanical many-body techniques, and multi-scale modeling. With Nomad, I will explain what Nomad is in a moment, we have a lot of experience, and the first step will be to fully integrate the Nomad laboratory into FAIRmat. We will also significantly enhance its services, and we will build all of this for all the methods mentioned and sketched in this figure. This brings me to the data infrastructure, which is coordinated by Hans Bungartz, professor for scientific computing at the TU Munich, and Wolfgang Nagel, who is leading the Center of High Performance Computing at the Technische Universität Dresden. Both men are involved in numerous IT and data infrastructure activities in Germany and Europe. The present situation and challenges are summarized in the gray box, but let me go to the goals. There is enabling individual scientists and research institutes to manage data following common principles with compatible technologies and a shared interface. Creation of a fair data exploration and sharing platform. Become a role model of data security. In order to identify possible limitations of all the FAIRmat developments and to demonstrate why this brings science forward, we have area E with 7 very different use cases. We will start from the present observation that there are many tools for data analysis, and many researchers in different groups have their own tools. This can be coordinated better and advanced. The coordinators of this area are Christoph Wöll from the KIT and Axel Groß from the University in Ulm. Together with their many task leaders, they will test and demonstrate the functionality of the FAIRmat data infrastructure and identify weaknesses to be improved. Show how the developed data infrastructure tools will significantly support the research of the various sub-communities. This, in fact, also will include smaller groups. Demonstrate the interfaces to and handshakes with other NFDI consortia. This interaction with others we consider important. It will help everyone. We are not starting from zero, but there is nearly 10 years of experience. Nomad, a European Center of Excellence, has built a FAIR data infrastructure already 2 years before the acronym FAIR was actually coined. Now the term is known worldwide, and Nomad is the largest store for computational material science data. 2014, we went online and we started to convince people to share their data. Not just the very few data that are shown in a publication, but all the data that were created in the study, even those data that turned out as not useful for the focus-oriented publication. We call this make data repurposable and recycle the waste. Don't throw data away if they are not needed for your own publication. These data may well be useful for a different study of someone else. One important aspect of Nomad that FAIRmat will advance is the accessibility of the data by what we call the Nomad Encyclopedia. With this, we offer an easy way to look at the data. Thus, the encyclopedia has an easy-to-use graphical user interface. You click at the periodic table and create the material in which you're interested, and then you can inspect the atomic structure, also moving it around. You can look at the band structure, at density of states, and you can also look at other aspects like phonons, specific heats, whatever is in the database. Interoperability will be an important issue of all FAIRmat activities. Again, in Nomad, we have extensive experience. There are more than 40 important and very different computer software packages. As we don't want to create any burden for the researcher, we let people upload the data in the way they are produced, very different for every software package. And then we have written parsers that read the data and normalize and convert the data. In this way, we were able to convince the community to participate. At this point, we have more than 100 million very expensive calculations. Here you see the leading computer codes leading in this repository and archive, and the number of uploads on a logarithmic scale. We have created metadata, and we are presently advancing that towards an ontology with other colleagues in Germany as part of a BMBF project. The resulting unique description of the data makes them fair, also in terms of the wanted AI readiness. One important aspect for reusability is the Nomad Artificial Intelligence Toolkit. These are tutorials and many Jupyter notebooks that people can use and also modify. One of our vision is that big data contain information that cannot be obtained when studying small data sets. And we can find structure in data, and we can create maps of materials properties. For that, we need to identify the appropriate coordinates. This is the AI component. Help us identifying physical, meaningful, interpretable sets of descriptive parameters. This is just one of our visions of the paradigm shift in the use of artificial intelligence. Here are again the areas which we like to address. And here you see Nomad. We call this a forerunner, which has shown us how big the challenges are and how we can address and solve them. Obviously, this is just a very tiny piece of what we need to do. We have achieved a lot in this tiny piece. This is the worldwide largest database in the field. This is FAIR. And beyond being a database, there is an encyclopedia and an artificial intelligence toolkit. This was work for 20 people for 5 years. That's a lot of work and just a tiny piece. The challenge to advance this towards other theories and modeling, and in particular towards synthesis and experiments, are enormous. Let me conclude by putting this in an even bigger context of the whole NFDI, and let me indicate where we are. The association FAIRDI and the DPG are important partners of FAIRmat. Since October last year, 9 consortia are working already. This figure represents them in terms of the structure of the Deutsche Forschungsgemeinschaft. There's engineering sciences, natural sciences, humanities and social sciences, and life sciences. In the natural sciences, there are chemistry and catalysis, but no physics. Obviously, we hope that this will change with the just ongoing second round. There are now 17 new applications for additional consortia, and we can expect that maybe 10, maybe 9, maybe 10 of them will be selected for funding. This selection is happening right now, during this week, and we can only hope that physics will become strong. We will know very soon. In summary, I hope I could give an impression what FAIRmat is doing already and what we are planning to do. We wanted to show that FAIRmat understands the immense challenges that we have to address and solve. We have good experience and ideas how to do this. In particular, we have a strong team, actually a very strong team of excellent scientists, SPIs, and task leaders. The goal is to help the basic sciences, that is by providing easy-to-use tools and infrastructure for fair data processing, storage, curation, sharing, and AI. And FAIRmat strongly emphasizes education and training, co-led by the chairman of the session, Erich Runge. Important ideas on what we need to do at the university level are coming from him, together with the DPG. The organizational principles of FAIRmat are design infrastructure and measures bottom up, advance basic science of condensed matter and materials physics, help the active researchers and don't create burden, lead by example, not by rules. And doing so, we are confident that integrating synthesis, experiment, theory, computations, and applications, FAIRmat will substantially further the basic physical sciences in condensed matter physics and chemical physics. And let me add that this will also reach out to chemistry, engineering, industry, and society. So this is it. Here you see the chairperson of FAIRmat, Claudia Draxel, from the Humboldt University in Berlin. Unfortunately, she was unable to be here today, and therefore she sent me. Please join the FAIRmat activities and visit our website. Tell us your needs and worries. The project needs that we all work together. FAIRmat is already very active and internationally visible. FAIRmat members are actually giving one FAIRmat-related talk every week somewhere on this planet since several years. Although we are not funded, the journal Nature has heard about our ideas at conferences. And Nature invited us in fall last year to describe FAIRmat as a nature perspective. This perspective was written by all 15 area leaders, and it was submitted about 3 weeks ago. We are happy to send you a preprint. Just drop us an email. Thank you very much for your attention.